Right, hello, grade nines. This is just a quick one. Or, I don't know, maybe not. Let's see how long it takes. But it's just a video to go through, so skip to the bits you need. And looking at working with TN, the general formula, working backwards with it, and then maybe just a quick look at a visual pattern. So let's kick off with things. Let's kick things off with at least a pattern, and I'm gonna go for one that goes 5, 8, 11, and just think to yourself what the next term would be. Okay, so I'm actually gonna pause before writing it, because just to remind you, hit pause so that you can get all that down, and then the video's not gonna pause for you now. So when you're given that, you're like, oh well, how am I gonna figure this next term? 5, it looks like we're just adding 3 each time, so it looks like we could just keep adding 3 and carry on our pattern. So that's a linear pattern, and then it's going up by the same amount each time, like in a line. Okay, so now you could be asked something like, cool, let's work out our general formula. So Tn equals. Now I'm jumping straight to the strategy because we've had some time to look at this to go, well, we're adding 3 each time. So for every n of these things, we're going to have added 3. So, if we've gone 1, 2, 3, 4 jumps along or something, we would have added 3 that number of times. So it must be something times 3. So we're going 3n because we're multiplying by 3. And then from there, we just said, well, our first term, so if we substituted in t1, we'd have 3 times 1. So far t1 would be 3. But actually t1 isn't 3, t1's 5. So we'd have to add 2 to 3 to get to what we know t1 is. So we'd have to add that 2. So let's add 2 to our formula. And let's check it with one of the other ones. So let's say we're trying to work out 1, 2, 3, 4, 5, t5. Well, t5 by our formula is 3 times, not 1, 1, 2, 3 times, wait a second, right, n is 5. So 5 plus 2, so, well, 3 times 5, 15, 15 plus 2, 17, cool, so that works. T5 is indeed 17, so our formula seems to work. And we can use our formula then to work out which term number is a particular value. So if I said to you, okay, so which term, let's try to check what I'm asking, which term has the value of, let's go 35. Okay, so now we're saying, well, we know that we've got this formula Tn equals 3n plus 2. So we know what the value of Tn is. We know that it's 35, but we don't know n this time. We don't know which number term it is. So we're going to just leave it as 3n plus 2, leave it as n. We've got one equation, one variable, so we can solve it. And so we're going to go minus 2, 33 equals 3n. Great stuff. Divide by 3, and we get 11 equals n. Seems to kind of fit in with pattern 1, 2, 3, 4, 5. So if we kept going, then 6 would be 20. Let's actually just check it, why not? So we're adding 3 each time, right? 20, 23, 26, 29, 30, where are we? 2, and then 35. That's what we're looking for. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yeah, so the 2 kind of match up. So that's cool. So that's working with Tn. Now, in the speedies and auto hires and yada yadas and that, there we're given something slightly different in that we had 0, and maybe for the first one we had 100, 200, and I don't know, I'm just going to make anything up here to go. For this one, perhaps we had 70, and perhaps for all of these, we were going up by 300. So 370, 670. So if you didn't speak at all, you paid 70 Rand. If you didn't go anywhere, you paid 70 Rand. Whatever our example would be. So in this case, if we're working out kind of still this idea of TN, but I know that it is maybe useful to kind of think of, well, X and Y, input and output. But if you go TN, it kind of still sort of works because we're just getting into our functions, which will be our next section. So if X was 0, Y was 70. So if we haven't gone anywhere, or if we haven't spoken on the phone at all, we always added a 70. And then what we were multiplying X by, well, when we went up by 100, we were going up by 200. But what we're interested in is what happens if you're going up by 1? Well, if you went up by 100, you went up 200. So if you went up by 1, you would just be going up by 2. So this is similar to the previous question now, where this would be 2x. Because for every 1 we're going up in our input, we're going up by 200. So that gives us our formula, y equals 2x plus 70. And maybe linked to this, if we had another one that was x, y, so this is, like, this was not speedy, this was the fast one, and this was the, was the other one quick one. So our quick one, we had 0, it's like those taxis. What is that? Speedy in that? That's what's stuck in my head now. So let's say this one had 0, 100, 200, and for this one you spent 50 Rand if you didn't go anywhere, and after that you spent let's go for, no, it goes up by 400. So then it's going to be 450, and we're going to have, so up by 400, 850. Well, winning at life, 850. Okay, so for this one, we'd have a different formula, and for this one, we'd have, well, y equals, well, if we haven't gone anywhere, we've added this 50. So I'm going to just subtract 50 here to go 400 just for our working out. So we know that to get from 0 to 100, we've gone up by 400. So for every 1 we go across, we're going up by, well, it looks like we're going up by 4 this time. Let's check it. Let's just write it down and check. So this would mean that if we input 100, in the merry way here. So it means that if we input 100, 4 times 100, 400 plus 50, so it seems to work. Okay, and the last bit here is, sometimes in this we're asked, algebraically show when these two companies would cost the same. So on the one side, you've got whatever this company was, this is their cost, and on the other side you got this one. So we asked, when are those two equal? So we asked, when is 2x, is it that side? When is 2x plus 70? When is that equal to 4x plus 50? So when is this cost equal to this cost? And then we're just going to solve it as we would any equation. So it's a balance. So if we subtract from one side, we subtract from the other. If we divide one side, we divide the other, and we'll solve. So that's the algebraic part, and that's just equations there. So you're going to go, well, they're 4x, 2x, so let's subtract 2x on each side, so that on the right-hand side, we've got 2x, because 4x minus 2x. And on the left-hand side, I'm going to say, well, we don't want 50, we want that to be plus 0, so we're going to subtract 50 on each side. So in this case, 70 minus 50 is 20. Okay, well, from there we're just going to divide each side by 2 equals, and so on this side we've just got x, and on this side we've got 10. So if you go 10 kilometers, if these were our taxis, then the price would be the same. And we could check it. So 2 times 10, 20, plus 70 is 90. So in other words, if you go 10Ks with this company, it would be 90 Rand. This one, 4 times 10, 40, 40 plus 50, well, that's 90 as well. So 10Ks, so that would be that. Okay, last piece of the puzzle, so to speak. And we're not going to go into in depth with this. I mean, it's you can have so much fun with these. But for these picture patterns, these you were told were non-linear visual patterns. And they're non-linear because if we just counted the numbers, we go, oh, there are 3 helmets. 1, 2, 3, 4, 5 times 2 is 10. 1, 2, 3, 4, 5, 6, 7 times 21, non-linear. So we're not using any of those, well, not any, but we're not using that strategy of that Tn equals how much is it going up by, because it's not going up by the same amount. So for these, you're going to break it up in any which way you like. I tend to see squares at the moment. Each time I do it, it's a bit different, but right now I'm seeing squares. So I think it's useful starting with the bigger one, the one on the furthest right, because I think it's a bit clearer where the pattern is than in the first one. So here, maybe I'm going to go, let's see, I can see a square there and a square there and a row here. Now let's see if I've got the same kind of thinking in this other one. Do I have a square, and a row? Do I have a square, and a row? Seems like I do. So I've got a square here, and this square is 3 by 3. This square is 3 by 3. And this one here is, I'm going to go 1 by 3. 1 across by 3 down. Okay. And this was for pattern number 3. So now we're saying which bits relate to the pattern. Here I've got a square, 2 by 2. Another square, 2 by 2. And this one, 1 by 2. And that's for pattern 2. So now we can start matching up the bits and bobs. Let's just, for completion, do this one. 1 times 1 for that square, 1 times 1 for that square, and 1 times 1 for that row. So it looks like this number here is always a 1. So if we went for our formula, it seems like we're going 1 times something to start with. Then we're timesing it by 1, timesing it by 2, timesing it by 3, so it looks like we're just timesing it by n. This here, by the way, was the first pattern. Okay, then we can go to our second bit. And our second bit here was, we've got a 1 times 1 square, 2 by 2, a 3 by 3. So 3 by 3, 2 by 2, 1 by 1. So we just got an n by n. Whether you write n squared or n by n, either way, really, we've got the idea. Now, I'm going to write it as n squared. I just, we saw squared, so, makes sense to think of them as squares. But actually, the other bit's the same. So we just got 2 of these n squareds, so that could be the way that we break it down. You may have done it very differently. It's quite possible that you saw a row of 3, 1, 2, 3, 4, 5, of 5, 1, 2, 3, 4, 5, 6, 7. So you had a 3, 5, 7, and saw it in some way, but that would kind of be a bit of our approach. Yeah, I hope you've skipped to the bits that you wanted. Enjoy, good luck, keep having fun. Love those journal entries. So, yeah, let's keep at it.